How's it everyone, and welcome to this week's C# video, where we're going to be talking about a concept that you definitely use every single day, but maybe don't give enough thought to how you use, and that is access modifiers. Let's dive in. So what do you use access modifiers for? Well, you use them to restrict the accessibility to different classes or methods or objects inside C#. For example, public, internal, or private. In this example, you'll see that the one thing that looks a bit different is that the private class is inside the internal. And the reason for that is you can't have a private class at a namespace level. So in this instance, what this will do is it'll say that I can access this class from inside this other class, but I can't access it from this class. So for example, if I just go here and I start declaring a local member, you can see it goes green. Whereas if I go to the public class and I try and use it, I can't access it. And a hint that you get from the IDE, if you try and use it like this, you'll see that it says you can't access that class because of its protection level. When you don't have an access modifier for your types, they'll default to internal. So all of these types have the same access modifier as these types. Next up is a relatively new access modifier, and it helps out with the problem that I used to have a while back. So when I wanted to create a class that I didn't want anyone else to use, I would normally put it inside my class. And what that did is it hid it from IntelliSense. So one of the downsides of this is it's very messy. Having a class in a class doesn't look great. And that's where we can use the file access modifier. Using that access modifier, you can see I can still use it here. To show this working properly though, I'll just need to move this to another file quickly. Which you can see, as soon as I've moved that out, I can still use that class type, but the program.cs can't because it's not in scope for it. For your members that are inside of your types, you also have public, internal again, and private. And for members, if you don't specify an access modifier, the default is private, except for when you have an interface. The default for a member in an interface is public. And the reason for that is that an interface's whole purpose is to describe what a type looks like. Not necessarily the whole type, but just the members that are related to that interface. So in this case, if I have to go inherit here from my app, you can see that it currently says that the type is not implementing this interface. To go and fix that, I can just implement that interface, and you can see now I've got a new public name, which at this point is not implemented. To clean this up a little bit, I'm just going to go and rename my previous type to name. Property. I just realized I've dived too far in. Let's step back a bit. Something that I haven't explained, which is pretty fundamental to this, is what does the different access modifiers mean? Now, it might seem quite straightforward. Something that's public is public, anyone can use it. Something that's private is private, no one can use it, or at least is very restricted on who can use it. Then what does internal do? Like, what is internal? Where is internal? Let's take a look. If I create an instance of the my app public, you'll see that off that, I can see the properties for name, which is our public name, which comes from our app, and I can see name internal. But note, as you probably expected, I don't see node private or node private too. And that's because I'm outside of the scope of the class where those private things are declared. So in this case, I could come here and replace this hard-coded string with name private, and that'll be able to reference it perfectly fine because it's inside that same class. And the internal access modifier is used to scope internally to the current assembly. So there's another access modifier that I haven't mentioned yet, and that access modifier is protected. So protected works very similar to private in that I can't use it outside of its class scope, but where it's different is that if I was inheriting from this class, I'd be able to access that protected member. Where you can see above, obviously outside, I still can't access it. And even with inheritance, I still can't access that private member from the class I'm inheriting from. Now, to show how internal works, I'm going to have to move both these classes to another assembly. Because as you can see here, if I try and go app dot, I am able to access those internal methods. That's because I'm in the same assembly. But once it's moved out, I can no longer access that. Although the public methods from both the app and the blueprint are available to me. And even with that moved out, I can still create my own local type, inherit from that blueprint, and use that protected member. So now I've gone and replaced all the magic strings to use the values that come from the most inner type, except I can't use the blueprint internal, even though I really do want to use it for this. And luckily, that's not a showstopper. So if you want to use types and members from assemblies that they're not declared in, you can use the internals visible to attribute. So the way we used to do this is have an assembly info file that has a whole bunch of different attributes in it. One of those would be assembly internals visible to, and then you specify the type that you want to allow your internals to be visible to. So you can see just by me uncommenting that, this now references the right property and we're able to use it. But ever since .NET Core, we've sort of stopped using this method, and then our preferred way is to go to the CSproj and add an item group that has an internals visible to node that says include, and then you put the type again. And then you can see once I save that, the squiggly line has gone away and I can now use this again. But what if there's a hybrid situation where I want to allow anyone that is internal or that's inheriting from my type be able to use it? Well, to show that, I'm going to comment this back out. So I'll get that red squiggly again, and I'll add this new property with a protected internal access modifier. So that will then let me use it in this app because of the protected access modifier. And then also if I had some other random class, it would be able to use that protected internal value. And you can see in this case, this class doesn't inherit from the blueprint. It just uses the public app and then accesses that property. And just to show that this is not because of the public app inheriting, we can also just use the app blueprint directly and then still gain access to that same property as we were. And the other combination that you can do is private protected, which will then mean that only types within this assembly that are inheriting from the type will be able to use it. So you can see here we've got a red squiggly here again because it's not accessible, as well as we've got a red squiggly above because it's not inheriting from the type. Now I've sort of hinted at it, but I haven't specifically called it out. Access modifiers help with how you can describe what the functionality of your code should be to people that are using your code. So in the example here, as I mentioned, if I wanted to use something that's internal to another assembly or that's protected by a certain type to only its inherited types, then I can use those access modifiers to help guide my users of my library or my co-workers into knowing how they should use the code. But access modifiers are not a security measure. By that I mean, don't store anything secret and think just because you made it private, it's private. So let's take the same example that we're in here. I want to access that protected internal because I like that value and I don't want to type it out myself. Maybe that gets calculated, and there happens to be a library that we're using at SSW that JK had to go and do this very same thing for because they had the access modifiers set in a strange way, which meant we either had to write the same code as them and hope that when they give a new version, they don't fix a bug or change the behavior a bit, or we had to turn to something that, generally speaking, how do I say this? Let's just say I'm not proud of some of the stuff I've done with this tech, and that is sometimes you just have to use reflection.
It's alive! In the name of God, now I know what it feels like to be God.
So what would that look like? Well, we start off with the type. So we want to get something off this type, so we get that type. Next up, we're interested in a property. The specific property is the blueprint protected internal property. Some binding flags that we need to pass in. So we know that this method is non-public, and it's also an instance method. And because this is a get property, what we want to do is get the value, and we want to get the value from this instance of the app blueprint object. And then because get value returns an object, we'll lastly just go and say as string at the end. Now you can see that all our red squigglies are gone, but just to prove that this actually works, you can see at the top here, I'm declaring an instance of the public year class. I'm then calling the example property, and that example property is doing this reflection onto the protected internal property, which is actually a private protected property. And then we're getting the value as a string. And you can see when that's run, it returns protected internal. And if I go here and just fix that to say, well, this is actually private protected, and run it again, you can see that it now says that it's private protected. So you can also use reflection like this for interacting with methods, but just know that there is a cost for it, and it's why you want to sort of try and stay away from this as much as you can. If you are able to contact the vendor and ask them to change the access modifiers, that'll probably be better. Maybe they can explain to you why it is private and you shouldn't be using that. Maybe there's an alternative for you. So to show the trade-offs of this, I've got a very simple benchmark here. What this benchmark does is it just news up this class. You can see I've got two methods here, one that says welcome private, one that says welcome that is public. For the instance method, I'm just calling it as you would expect. And for the other method, I'm doing some reflection again. This pretty much looks exactly like the other one, except instead of saying get property, I'm saying get method. And then instead of get value, I'm invoking the method on this instance of the type, and I'm passing this through as parameters to that method. So you can see in this case, the reflection took double the amount of time to run as just calling the method directly. Although for this specific case, 30 nanoseconds is negligible, if you have a hot path of your code that's continuously doing reflection, that could end up doing or creating big performance issues in your application. Now, before I let you go, earlier I mentioned the file modifier, but I didn't show an example of it working. So let's take a look at what we have here. So I have a public interface called our window. And then we have a class here where I wanted to return an instance of an our window, but I didn't have an implementation. So what I did was I created a magic window, and you can see this inherits from our window. And for its implementation, it returns file. Now in this case, if I try to move this class to say this other file, as you would expect, that wouldn't work because it doesn't know where that is. But when we try and use it, so we say my app, we say app.getName, which is this method, then everything works as expected. We run it and we get file, which is exactly what the magic window had as its value. Now you can see that the magic window is in the other lib namespace, but if we go looking around that lib, you can see that we don't see the magic window. Even if, as I mentioned earlier, we are inside this other file, if we do other lib dot, we don't see this magic window at all. And this is just some compiler magic. So you can see that if we go and write out the type for this class that has a file accessor gets a generated type name. So we won't find it with IntelliSense. The IDE and Roslyn does a good job of hiding that from us, as it's expected, and the feature ends up working quite well. Honestly, I haven't used the file accessor myself that much, and I've only seen a couple of places in the .NET framework where it's actually being used at the moment. Now, if we didn't have access modifiers, we'd have to do stuff like use this, don't use this, and check if you should be using this, probably as part of our method names. Maybe we hide it somewhere in a prototype of sorts. Well, that's all I have for you today. If you found this useful, please remember to like the video and share it with your friends. If you have any thoughts on this video or others that I should maybe do, leave them down in the comments below. And until next time, cheers.